Okay, in this lesson, we are still going to be solving logarithmic and exponential equations. This is just the second part. So, solving logarithmic. And exponential equations. Number 2. All right, it will say to solve each equation. The first one we are going to solve is log base 3 of 4x minus 2 equals log base 3 of negative 5x plus 5. Okay, so one of those properties of logarithms that we looked at said that if you have one log on each side and it's the same base, right? Basically, you can get rid of those. You could also add them in if it helps. So in this case, we have log base 3 of this, log base 3 of this. There's no other additional terms. So we can drop the log base 3's, and then we just have 4x minus 2 equals negative 5x plus 5. And then we can solve that pretty easily. We just add 5x. We get 9x minus 2 equals 5. And then we would add 2. So we get 9x equals 7, and we divide by 9. X equals 7 over 9. And then you have to check this. So what we're doing is we are checking, because if it makes whatever you're taking the log of negative, we know that cannot work. So to check it, we plug in, we have log base 3 of 4 times 7/9 minus 2. Does this equal log base 3 of negative 5 times 7/9 plus 5? So we could check this on our calculator. We would do 4 times 7 over 9 minus 2. So we have log of that, right? Or we could actually make it a fraction. That would be even better. So log base 3 of 10 over 9. Does this equal log base 3 of negative 5 times 7 over 9 plus 5? Does that equal log of 10 over 9? Well, they're exactly the same. It's not a negative number here, so that means this is my solution. Let's do another one. So here we have log base 5 of x plus 3 equals 1 minus log base 5 of x plus 7. Now here you can see not only do we have 2 log base 5's, but we also have another term. So we can't do what we did up here because we've got this extra term. So if you have an extra term, then you've got to get your logarithms on one side and everything else on the other. So in this case, I need to get this log base 5 to the other side. So what that gives me is log base 5 of x plus 3 plus log base 5 of x plus 7. And we have on the other side, we got rid of this, so we just have equals 1. Now I want you to remember your properties of logarithms here. When you have logarithms that are combined with addition, remember that changes to, we can combine them and condense them into one logarithm with multiplication. So that means we have x plus 3 times x plus 7. And here this equals 1. Well, at this point, what do you think we need to do? You have one log and it's equal to a number. So in the last lesson, remember we changed this to exponential form. So that gives us 5 to the first power equals x plus 3 times x plus 7. Well, then we actually need to multiply that out. 5 to the first power is 5. Here we FOIL. X times x is x squared. X times 7 is 7x. 3 times x is 3x. And 3 times 7 is 21. So at this point, we can combine like terms. So I could subtract 5. And I can combine these two. And I would get, I'm going to come up here, x squared plus 7 and 3 is 10x plus 21 minus 5 is 16 equals 0. And now we have a quadratic equation. Remember, to solve quadratic equations, you can use the quadratic formula, or we could factor. We do 1 times 16 is 16. That gives us 1 and 16, 2 times 8, and 4 times 4. Well, to get 10, right, we can use 2 and 8. So we would have x squared plus 2x plus 8x plus 16 equals 0. We factor by grouping. Factor out an x, we get x plus 2. Here we could factor out an 8, we get x plus 2. So we get x plus 2 times x plus 8 equals 0. Well, that would tell us that x equals -2 and x equals -8. But we have to check both of those, right? So here I'm going to check x equals -2. We plug in log base 5 of, well, -2 plus 3 is 1. Does this equal 1 minus log base 5 of -2 plus 7 is 5? Well, we could use our calculator at this point to check it. So here, if you don't have the option to do this, right, then you have to use change of base. I'll do both. Here, we would choose this. We have log base 5 of 1 equals 0. And then we have 1 minus alpha y equals, we go over to function 5, log base 5 of 5, we should know that's 1. That equals 0, so this one checks. Remember, if you need to do change of base formula, to do change of base, you would do log of 1 divided by log of 5. And again, it'll give you 0. If you had to do this side with that, you'd do 1 minus in parentheses log of 5 divided by log of 5. And that gives you 0 as well. Then we need to check x equals -8. So here we have log base 5 of -8 plus 3 is -5. And honestly, right there at that point, I can stop because you cannot take the log of a negative number. I'll show you on your calculator. If we do alpha y equals, we do our log base, we have 5 of -5. It's going to tell us it's not a real answer. So you can never take the log, no matter what base, of a negative number. So it does not equal -8. Therefore, our only answer is x equals -2. Okay, let's look at another one. If we have log of x equals log of x plus 5 minus log of 2. So here we have 3 logarithms, right? So if we get 1 on each side, we could solve it like this. Well, if we look at this, is there a way to combine these? Well, yeah, because subtraction, we can combine them with, for logarithms, remember, subtraction can be combined into one log with division. So x plus 5 over 2. And now, because we have the same log base on each side, we simply just set x equal to x plus 5 over 2. And then we just solve it. So here, to get rid of that fraction, we can multiply both sides by 2. That cancels. We get 2x equals x plus 5. Here, to solve this, we would subtract x. That gives us 1x equals 5. And then we can check it. So here we plug in log of 5. Does this equal log of 5 plus 5 is 10 minus log of 2? Well, you could do that on your calculator. Log of 5, is that the same thing as log of 10 minus log of 2? Are those the same? Yes, they are. Therefore, that is my solution. Okay, let's look at another one. Looking at D, here, instead of using our common logarithm log, which is base 10, or a base 5, we're going to use ln. Remember, ln is log base e, right? So ln of x minus 2 plus ln of 6 equals ln of x. Well, again, we've got too many logarithms, right? We need one on each side. Well, because of addition, we know those could be combined with multiplication. And now we have one log on each side, so we just simply have, I'm going to move this around and say 6 times x minus 2 equals x. And to solve that, we would distribute. That gives us 6x minus 12 equals x. We can subtract 6x. That gives us negative 12 equals negative 5x, and we divide by negative 5. So that would tell me that x equals, a negative over a negative would be positive 12 over 5. And then we have to, of course, check it. So we would have ln of 12 over 5 minus 2 plus ln of 6. Does this equal ln of 12 over 5? Well, let's look at it. Here we have ln, and I'm going to put in parentheses 12 over 5 minus 2 plus ln of 6. Is this the same as ln of 12 over 5? Yes, they are. It checks, and this would be our answer. Okay, we're going to do one more of those. So looking at E, if it gives you 32x minus 5 equals 64. So we've already done one somewhat like this. Actually, we're going to do two more. We'll do this one and one more. But we've already done something similar to this, right? These are exponential functions. So we need to see if our bases could be the same. Can we get these bases to be the same? Well, 32 and 64 are not the same, but 32 can be in terms of 2. So 32 in terms of 2 is 2 to the 5th power. So I'd have 2 to the 5th power times x minus 5 equals. Can we get 64 out of 2? Well, we know 2 to the 5th power was 32. Is 2 to the 6th power 64? It sure is. So that means that this is 2 to the 6th power. And remember, if you get your bases to be the same, we can drop them, just like with logarithms. If we get our bases to be the same, we can drop them. So here, we would have 5 times x minus 5 equals 6. Well, that gives us 5x minus 25 equals 6, and then we can add 25. So we get 5x equals 31, and we divide by 5. So x equals 31 over 5. And then, of course, we can check it. Here we'd have 32 to the 31 over 5 minus 5. Does this equal 64? 32 to the, now some of you guys are going to have to use more parentheses because some of you don't have the calculators that make the exponents stay up in there. So if you don't, make sure you use your parentheses around the whole exponent. In this case, we just have to do 31 over 5 and minus 5, and that is 64. Therefore, this is our solution. All right, one more. Let's look at F. If we have 2 to the x squared minus 28x plus 19 equals 16 to the 4 minus 6x. Well, the first thing is we need these bases to be the same. I can get 16 in terms of 2. So here I'd have 2 to the x squared minus 28x plus 19 equals 2. Well, 2 to the what power gives us 16? 2 to the 4th power. And then we'd have times 4 minus 6x. So here we have x squared minus 28x plus 19 equals, I can distribute that. 4 times 4 is 16 minus 4 times 6x is 24x. So here I need to combine like terms. I would subtract 16. I'd add 24x. And we have a quadratic equation. So x squared minus 4x plus 3 equals 0. When we have a quadratic equation, remember to solve this, we can either use the quadratic formula or we could factor. I'm going to try and factor. I'd have 1 times 3 is 3. My factors are 1 and 3. Well, I can get negative 4 out of that. I'd use negative 1x and negative 3x. That gives me negative 4x plus 3. And I factor by grouping. Here you could factor out an x. We get x minus 1. Here we factor out a negative 3. We get x minus 1. This gives us x minus 1 times x minus 3 equals 0, which means x equals 1 and x equals 3. Then you have to check those, right? So let's check x equals 1. You'd have 2 to the 1 squared minus 28 times 1 plus 19. Does this equal 16 to the 4 minus 6 times 1? Well, that would give us 2 to the 1 squared is 1 minus 28 plus 19. Does this equal 16 to the 4 minus 6? Well, 2 to the 1 minus 28 plus 19. Excuse me. Does that equal 16 to the 4, not times, but minus 6? Those are the same. It does check. Then we have to check x equals 3. So we would have 2 to the 3 squared minus 28 times 3 plus 19. Does this equal 16 to the 4 minus 6 times 3? Well, 2 to the 3 squared is 9 minus 28 times 3 plus 19. Does that equal 16 to the 4 minus 6 times 3. Those are the same. They check. So our solutions would be x equals 1 and 3. And those would be your answers. So that is the second part of solving logarithmic and exponential equations. We will do one more part